everyone, today we're looking at adding and subtracting in scientific notation. So you need to turn to page 32 in your yellow packet. All right, so this is actually the first problem on that page. However, I don't want you to write this down yet. So when we add in scientific notation, here we have two numbers. You can see their factors and their power of tens are different. So this is 4 and this is 5. So you could write both of them in standard form. Write it out like this. You could add them. But would you want to do that? This isn't that hard, but if you had a power of, let's say, your powers of 10 were like 20 or 30, that's a lot of zeros to write. So we want to be able to compute in scientific notation. So when we are adding in standard form, it's over here in yellow. Like it's almost like we're lining up all the place values and then we add them. So we have to think, how do we make the place values line up but keep it in scientific notation? So that's what we're going to look at today. So you can write this down now. There are two different ways of doing these problems, and this is for adding and subtracting. You are going to change the numbers so that the powers of 10 are the same. You can make the powers, change them to be smaller, or you could change them to be larger. You're not changing the value of the number, so it doesn't matter what you do. So I'm going to show you both ways. So here's that first problem. So what I did here is went to a smaller power. That's what we're working on. So here we have this power of 10 is 4 and this is 5. So I went ahead and brought everything to the fourth power. So in order to do that, I had to multiply by 10 here. And now I have, which would take away 1. So now I have both of my numbers, their power of 10 is 4. Now we can add them. So what we essentially did is lined up those place values so we could add. So we take the factors and we add them together. And this is, we get 99.29. Make sure you're writing all of this down in your notes. And then we're still not done because we need to write this in scientific notation. So the factor would be 9.929, and then we'd have times 10 to the fifth because we had to move this decimal 1 to the left, which is dividing by a 10. So you have to add 1 in the power. So that's how you get 10 to the fifth. Okay, so here is an example of changing it to a larger power. In this one, we went down a power to 4, and now we're going to go up to 5. So what we need to do is change this number to go up a power. So instead of 4, this is now going to be 5. So in order to do that, we have to divide by 10. So that moves our decimal place over here. And we add the 1 to the power. So that's 10 to the fifth now. So now we've created our place values are lining up. So now we can go ahead and add, and then we get 9.929 times 10 to the fifth. Obviously, we should get the same answer as over here because it's the same problem, but you can see two different ways of doing this. In this case, I actually prefer going to a larger power because I recognize that in doing that, I'm not going to have to convert to scientific notation at the end of this problem. It's already in scientific notation, and you'll start to see that pattern. All right, so we're going to try these two. So this one, I'm going up a power. So in order to do that, we have to divide by 10. So that adds 1 to this 3 on 10, the power. So then we can combine our factors. We can go ahead and add those. You still have times 10 to the fourth. And then in this case, we're still not in scientific notation, even though we went to a larger power. So we still have to convert to scientific notation. So here would be your answer. Over here at this problem, you have times 10 to the third over here, and you have 10 to the fifth. Now, a problem like this, it's like 2 powers away from each other. You could make them all to the fourth power, or both to the fourth power if you wanted. I ended up going to the fifth power for both of them, because then I can see that I won't have to convert into scientific notation afterwards. Okay, next we're going to look at subtracting. So on page 33 in your packet, it's the same exact process for subtraction. So I'm going to show you an example for changing to a smaller power and then changing to a larger power. So here we're going to a smaller power. So that means I am going to take this down to the 7th power. So I have to multiply by 10, so that subtracts 1, and now I'm at the power of 7. I can combine those factors, and I'm still not in scientific notation yet, so I now have to convert to that. Now we have changing to a larger power. So this, we're going to go up to the 8th power. So to do that, I had to divide by 10, which adds 1 to the 7. And we can subtract those. And in this case, we are already in scientific notation. So once again, going to a larger power actually was a little bit more efficient in this problem. All right, here's 2 practice problems. Work through those. I went to the power of 9, so I had to move this 2 place values to the left, which is dividing by 100, which would add a 2 to the power of 10. And then we can subtract, and we are in scientific notation. Here, I also went up to a larger power of 8, and we subtract, and we are already in scientific notation. Last 2 is the stamp check, so you need to complete these, and then you can check your answers. This would be 8.9042 times 10 to the 9th, and the second one would be 1.233 times 10 to the 6th.